Hello everybody, welcome. I decided to shoot this screencast to help the people who are learning MPS to get over some typical issues that you face when you start creating your first domain-specific languages. So what I'll do here, I'll create a very simple, not necessarily very useful domain-specific language, and as I develop it, I'd like to show you some good practices that should help you create those languages easily. So we'll do the basic language structure. We create a structure of a language, we'll do an editor, and then we'll create a generator that will generate Java out of our domain-specific language. What we want to generate looks something like this. So I'd like to create a very straightforward domain-specific language, out of which I get a final class which will declare integer constants that then the rest of my Java application can use. But this class, the one you're looking at, will be generated from MPS, from a much simpler piece of code than you see here. And this is where we are heading. So this is the language that we'll create. A DSL that allows us to create a list of constants, and we can give it a name, myConstants in this case, so it will be generated into myConstants.java Java class. And then we have individual constants here, so we say we've got a constant minimum and default, which is minimum plus 50, and maximum, which is minimum plus 100, and we have name, which is a string constant, and boolean constant called flag, and so on and so forth. And we can add more constants, we can refer to the constants that are defined earlier in the file. So we might say that foo is name plus whatever bar. Additionally, we get an IDE support for our language. I mean, that's how things work in MPS. So now, looking at this usage of name, we can highlight all usages of name, or we can jump to definition of name, and now we just hit preview generated text, and we immediately see what gets generated out of our DSL. Okay, so this is what we are going to build in this screencast, a language that allows us to do exactly this. Well, I said it won't be necessarily a very useful domain-specific language, but it should help you understand the basics of MPS. And we'll start from the very beginning. So we'll create a new project. I'll give it a name. We'll create a new language inside that project and a new sandbox solution. And well, that's what we need. Now, first, when you design a language, the first thing we'll do we'll create a structure for the language. So now in the structure, we'll create a new concept, and I'll call it constants. So it's a base concept, and it should have a name. So that's why I make it a named concept. So the name of the constants, once you give it a name, it will become the name of the class that we generate. So that's why I give it a name. And next to it, I'll create a concept called constant. Again, a base concept. Again, it should have a name, and it should also have a value, the value that the constant should have. So it will be a property called value, and the type will be integer. Okay. Now editing a constant. So now we define the concrete syntax for our constant. So when you define a constant, you should what I would like to see on a screen, I'd like to see a label constant, a colon, and then the value, then the name of the constant, and then the value. So let's do it. So typically I start with a square bracket minus, which will create a collection, an indented collection for me. Now inside here, the first thing I want is a constant, so I go constant, and the constant could be So that's a constant value I want to see on the screen, and so I give it a text constant. That's not necessarily the best name because it might puzzle people, so let's call it my constant, so you can distinguish, this is my constant, not the name of the field, which also happens to be constant. So my constant and colon. Now here we would like to have the name, so the name, if I press the left curly brace, I see here name, so that's the name of the constant. And then perhaps I could give it a colon, so let's put a colon in there. So again, a constant field. This time it will have the colon string in it. And now we have the value. So that's the editor. This is how it should look on the screen. And back to constants. So this is the list of constants that we want to generate. So that list of constants should have children, and children will be the individual constants that we want. So the type will be constant. So we have a constant. We'll give it a name, constants. Now we don't need to refactor. I just changed the name so it prompted me for refactoring. I don't want that. I'm sure nobody refers to this. So now we have so we have constants. Now obviously the cardinality needs to be different. So we want 0 to n constants. That's it. So now we have a list of constants and we need an editor. Editor where we could edit constants. So again, a square bracket minus, now we have a collection. And now we want to say, so at the top we say, we say constants. So again, a constant field, constants. Now we should edit the name, so the name of this set of constants, if you like. And now we need a collection of constants. So now I do parentheses, the left parent minus. So basically to create a vertical collection of children. So the children are the constants that we defined. And now we need to set some extra properties to lay it out nicely on the screen. So what I'll do here, I'll open the inspector, and in here now we say that indent layout indent should be true. So basically this will be indented, and it should also be on a new line. So indent layout on new line. Perfect. So now we have constants, name for them, and then we have the constants listed vertically. One more thing for the constants, it's a root concept. So it will be in the root of the abstract syntax tree, so it can be the root. So that should be it. Command F9 will regenerate. So now we build the language, and once we have that, we can test it. We can try it in the sandbox. So we can create our own list of constants now. So I jump here and say I want new. I open the model in here, the sandbox, and say new set of constants. I give it a name. So that's the name of the set, and now we can create constant. So my constant, well, the first one, whatever, maximum 100. Hey, and it's that's not what I wanted. So we have a list horizontally, not vertically. So let's go back to the editor for the constants and check what's wrong in here. So we should make it. Let me fix that. So once again, we do left parent, and okay, yeah, my mistake. I used I used the wrong collection, so we have to use. I want to use vertically sorted or vertically organized children. So this is the right one. Constants and indent layout on new line. rebuild. Alright, and here we're back. So minimum 0 and whatever rate should be 6, I think, whatever. So these are my constants. But now, alright, so I've got my simple domain specific language running. I can edit it, I can save this, but I can't generate Java yet. So this is still just my, I can edit it, but I can't do anything useful with it. So now the last part is we need to create a generator that will generate plain Java out of this. I'll start from the simpler thing, that's the constant itself. So here's the constant, and with the constant I create a generator. So it will be a template. No name needed here, so I say OK. So now what I got is some sort of template for what I want to generate, and here we got some kind of list of all the rules that apply when we generate. So when we reduce a constant to do something, we use this rule, we navigate to it. So this is it. So this is what we want to generate out of it. So now we have to somehow wrap it. So we create a class first. So here is some dummy foo class that won't be generated. That's just in a kind of so that we have an abstract syntax tree. So we have context. So we have a class, and in that class we need static fields. And that's where we are going. So static fields. We need a static field of type integer. Well, and has some name and has some initialization value, let's say 0. And now we need to parameterize this template. So this is still, not very useful. That doesn't take into account anything that we typed in our language. So now we have to apply it to this. So what we need to replace the constant name with the name of the constant that we define in our language. So Alt Enter helps us. Well, I see final. Yeah, I want them final. That's the first hint I use. Well, and then the second one, the most useful. I need to change this to node.name. So I need to take the name of the constant and replace it, or replace the value constant name with it. So now notice, now this whole line is marked as template fragment. So this is like part of the template that will be used in the generated code. And now in the generated code we'll get private static final end, and now we'll get not constant name but whatever is down here in the in the inspector, which is node name. So the name of the node, and the node, if we check with Command Shift T, is a constant. So that's what we want. So we get the name of the constant, we get it up here, and for the value we don't want the constant to be initialized to 0. We want it to be initialized to some to the value that's specified as part of the constant. So I think it's called value. So here we go. So property macro node.value is the one we want here. And now I go to the constants thing. So basically this concept that contains those constants, and I want this to be generated into a Java class. Alright, so I go to main, and now I want a root mapping rule. So basically I want to take a root and generate a new root out of it. So the root I want to take is the constants concept, and I want a new root template, and the root template will go for class. So let's jump there. So this is the template that will replace constants with a class. Now the class needs a name. I definitely don't want this default name. I want the name of the constants concept, and I want the same for the constructor, obviously. Alt enter name. Good. So now we have the class name and the constructor name done correctly. And now we need to put somewhere the individual constants. So let's do it. So they are static fields. So private static integer my constant. Yeah, we could make it final. Alright, then we need to give it a value. But this thing will be replaced. Oh, no, this thing, sorry, I need to take a little bit more. So now we'll loop. If you look down in the inspector, now we're looping over all the constants, and for each of them, basically we'll replace whatever is in here. We need to replace it with the constant itself. So to replace it, so now we loop. Now we need to say we want to replace it. So we go node macro, copy source, and we replace node. So now what happens? We have a loop. We loop over this over all the constants in the constant set, and now for each of the constant we replace whatever we've typed in here. So this is irrelevant, it's just, you know, field declaration, but anything in there would work. We replace this with node, but node itself is node itself, that's a constant. So constant itself has a rule that will say that constant needs to be replaced with this using this rule. It will be replaced, yeah, well, using this. So this is the rule for replacing the constant. So now we should have all the places, all the stuff in place. I'll rebuild the language. Okay, we're getting to it. Back to my constants. Now I have my constants here. So now if I say generate Java from this, so this is what we get. We get a class called myConstant and has private static final integer maximum, minimum, rate, you know, constructor. So it generates a valid Java class out of the DSL that we have here. Okay, so that's it. So that should give you an idea how to create a very simple language. And it showed you how to use in the generator how to use macros, the property macros and the node macros to transform your domain-specific language into Java. I hope you found it useful. That's all for now. Goodbye.